solve the absolute value inequality. We have here an inequality, and as part of that inequality, we have an absolute value. You'll recall that an absolute value symbol goes ahead and does two things. It either leaves what's in the absolute value alone, or we take the opposite of it, the negative of it, depending on whether or not this thing inside is positive or negative. Right? At the end of the day, this absolute value of whatever is going to be a non-negative thing. So if it's non-negative to begin with, we leave it alone. If it's negative, we turn it into a positive by multiplying by a negative number. So this absolute value really means two different things depending on context. So we have one inequality listed, but we actually are going to be dealing with two inequalities. Why don't we go ahead and get the absolute value on one side of the inequality by itself. So I'll add 4 to both sides as a starting point. So I added 4, and now we have our inequality. In our book, it tells us one way to proceed, and that's to just write down a formula. Our formula tells us that anytime we have absolute value of something greater than a number, we can go ahead and write x greater than that number and x less than the negative of that number. And either this first one or that second one are going to be solutions to our original, to our inequality here. The other way we could go is go back to first principles thinking, okay, what's absolute value mean? Well, absolute value means 3x minus 8 if 3x minus 8 is a positive thing. Okay, so if it's positive, we get 3x minus 8 is greater than 4. If, on the other hand, 3x minus 8 is a negative thing, then we want to make it positive by multiplying it by a negative 1. So we'd have that. So that's how we'd have this be a positive thing. That is, the absolute value will do what we want it to do if 3x minus 8 is negative. Okay, let's get rid of this negative, so I'll multiply both sides by a minus 1. And then we get 3x minus 8. We get a negative 4. I multiply by a negative, so I have to switch the direction of my inequality. And you'll see this equation and this equation are the two equations that we'd get by just applying the rule directly, right? If I see something like this, absolute value greater than a number, I do whatever was in the absolute values greater than that number, and then I do whatever was in those absolute values less than the negative of that number. So either remember that or just remember what an absolute value does. Okay, well, now we have two inequalities to solve, so let's do it. Let's add 8 to both sides over here, so we get 3x greater than 12. Let's divide both sides by 3, so we get x greater than 4. So there's some of our solutions anytime x is bigger than 4, so that's this interval here, 4 out to infinity. Let's do the same thing over here. Let's add 8 to both sides, so we get 3x less than if we add 8 to negative 4, we get a positive 4. Now let's divide both sides by 3, we get x less than 4/3. So this is the interval from negative infinity all the way out to 4/3. And if I'm in this interval, we have a solution to this. If I'm in that interval, we have a solution to that. So I want to combine these two intervals with a union. Doesn't matter if I'm here or here, as long as I'm in at least one or the other of these, one or the other of these, right? I have a solution there. Okay. So we're done.